Hello friends, welcome back to your channel. In this channel we try to solve the previous year's physics question papers of NEET undergraduate exams. This is also helpful for those who are appearing for JEE mains. This is solved in a very student friendly manner so that you can understand and apply the concepts. We have included all types of questions appearing in the exam so that your preparation is complete. If you like the content, we urge you to like the videos. This motivates us to create more content for you and help you in your exam preparation. We also urge you to subscribe to the channel so that you are immediately informed of any content added to the channel. If you have any doubts, then please feel free to add in the comments section. We will revert to you at the earliest possible. So without much ado, let's start solving the problems. So in the previous slides, in the previous video sessions, we have solved from question number 1 to question number 6. So in this session, we will be solving from question number 7 onwards. So this is question number 7. In this question, it is stated that there is a force of 10k. So right, this force is of 10k. So let's understand what does it mean. Okay, so the magnitude of force is 10k. So it means, so 10k, let's split it into 2, right? 10k, when I write, it means 10, there is a number, and k is the vector here. Okay, so k vector means that this is acting, since only k is there, right? There is no I, no j, no k, no I, no j. So it means this is acting in the k direction, or rather this is acting in the z axis direction. Okay, and what is the magnitude of this? This is 10. Okay, this is the value of the force. Okay, and now what is the position vector? Is 2j, right? Position vector is 2j, so r is 2j. Okay, now what does this mean actually? So it means that where is the body? The body is somewhere here. Now this is when we say ijk, right? When we say ijk, we normally what do we do is that I we take as a vector along the x direction, j we take as a vector along the y direction, and k normally we take as a vector during the in the z direction or z axis direction. Okay, so when I say 2j, it means this is the magnitude is 2, so it is at this point. It is on the y axis, right? In this also you see there is a, when I say r is 2j, there is no I component, there is no k component. It means it is on the y axis. Okay, so now it is very simple now. So as we saw in the previous concepts, if you go and brush up the concepts, so what is tau? We had mentioned tau is equal to position vector multiplied by the force. Okay, so what does it mean then? Let's multiply this now. Ijk. So what is r? R is nothing but 2j, right? So when you say 2j means 0 to 0. Okay, only 2j is there here. Okay, and what about the force part of it? Force is 10k. So 0, 0, 10. Okay, so we just need to solve this. So we'll take I common here, I, then 2 into 10 minus 0. So this is equal to I into 2 into 10 is 20, right? 20 minus 0, so it remains with 20, minus j. If you see j, if you take j here, if you take j, then I need to multiply 0 into 10 minus 0 into 0. So 0 into 10 is 0, minus 0 into 0 is also 0, right? So it means 0 minus 0 becomes 0. What about k part of it? So we need to write plus k. Okay, k, so 0 into 0, right, minus 0 into 2, which is again 0 into 0 is 0, 2 into 0 is also 0, so 0 minus 0 remains with 0. Okay, is 0. So what is the value of here? There's 20i, right? So this is the value of torque here, right? So the answer is given here, the answer A. Okay, So now let's go to the next question now. In this question, it is given that there is solid sphere which is placed on a smooth horizontal surface. So since it is placed on a smooth horizontal surface, it's given here, right? That is smooth horizontal surface. Since a smooth horizontal surface, it implies that there will be no friction, right? So uh, there will be no friction here, right? No friction force acting. So basically what it means is that if this is a sphere and if it is trying to roll in this direction, trying to roll, right? So there will be no friction, right? Friction is missing. So if friction is missing, okay, now how is the force being applied? Force is being applied like this at a certain height h. It is given here to the lowest point. Okay. So we normally know that rolling, if for rolling, okay, we need friction. Okay, and in this case there is no friction, right? So if the friction is not there, so it means the body will not roll. So at whatever height you apply the force, the sphere is not going to roll, right? So let's look at the answers. What is going given here? The answer is given here is that height is equal to 0, height is r by 2, height is 2r. So none of them is relevant because anyway the rolling will not happen, right? So the answer will be acceleration does not depend on h in this case. So friction is not there. Okay. Let's move to the next problem now. In the next problem, what is given there? We have a force given to us. So force is given to us. Okay, and we need to have we need to find the moment of force, which is nothing but the torque. Okay, so to find the torque, we know what is the formula for finding the torque. So torque, we know that equal to position vector cross multiply with the force. This is what we know from the concepts. Now, how to find the position vector? To find the position vector, we need to know two coordinates, right? At which point is the force applied and at which point will it rotate? Okay. So in this case, it will rotate around this point, which is given to us 4 minus 4 minus 5. And okay, there's a typo in this problem. The typo is that this should have been 4, 5 minus 2. Okay, this is given to be by mistake 4, 5, 2. Nevertheless, so this is 4, 5 minus 2. So this is 4, 5 minus 2. Okay, right, so let's cut this. Fine. So the point at which the force is applied is 4, 5 minus 2. And we know the magnitude of force 3i plus 2j minus 5k, and it is supposed to rotate around the point 4 minus 4 minus 5. So how do you find the position vector now? So position vector is equal to, at what point will it rotate? It's 4, 5 minus 2, right? It is 4i plus 5j minus 2k and minus the point at which it around which it will rotate, 4 minus 4 minus 5, 4 minus 4 minus 5. So this is a point it will rotate, right? So this will find the position vector. 4i minus 4i, so this gets cancelled, 0. Plus 5j and minus 4j, this becomes 9j. Sorry. This is 9j. Then minus 2k and plus 5k, which becomes 3k. Minus 2k plus 5k becomes 3k. Okay, so this is R. So how do you find torque? Torque is I J K. Okay. R cross this formula. So what is R here? 0, 9, 3. And what is force is 3i plus 2j minus 5k. 3i plus 2j minus 5k. So we just need to find find the value of this. So in this case, we take I as a constant here. So 9 into minus 5 is minus 45, and minus 3 into 2 is minus 6. So this becomes I to minus 51. Okay. What about J now? We take J part of it. So 0 into minus 5 is 0, and 3 into 3 is 9. So this becomes 0 minus 9. Okay. Plus K. We take the K here. So 0 into 2 is 0, minus 3, 9 into 3, 27. Become minus 27. Okay. So the answer will be tau is equal to minus 51I plus 9J and minus 27K. This is the answer for torque. There is a typo in this, so this should have been instead. So this should have been instead minus 51I plus 9J, okay, minus 27K. Okay. So apologies for the typo. Okay. Let's move to the next problem now. In the next question, it is given to us that there are two bodies P and Q which are moving concentric circles. Concentric circles means they have the same center. O, for example, they have the same center. So the radius is RP and RQ. So obviously this is the RP part of it. Okay, so this is RP, and this is RQ. Okay, with speeds of VP and VQ respectively. The time period of rotation is the same, so we know the time period. So the time period is given to be the same here, and we need to find the angular speed. Now, if you remember the formula we had given in the concept, so it told that omega is equal to 2 pi by t. Okay, so it means omega is actually just inversely proportional to t. Okay, I think this we need to remember. So if we have omega 1 by omega 2, okay, this is equal to T2 by T1. Okay, T2 by T1. Right. So now it is given that these two bodies have the same time period. So it means this is equal to 1 upon 1, which is 1. Okay. So if that is the case, then the relation between W1 and W2 will be 1:1. Okay. I hope you are able to follow this, right? So now let's move to the next question now. Wheel is rotating at an angular acceleration of 4 radians per second square. So angular acceleration is given as, so I can write alpha it's equal to 4. Alpha is given to me 4 radians per second square. Okay. We also know that initial angular speed, which is W0 is equal to 3 radians per second. Okay, and time is given to be 3 seconds. So I think it is very simple. So we need to find the angle it is rotated. Angle means we need to find the theta. So this is a very straightforward application of formula. We know that theta, if you go to the concept, we have a formula, theta is equal to WT plus half alpha t square. Okay, it's analogous to linear motion, you know that, right? S is equal to ut plus half a t square, the analogous to the linear motion. So now coming back to this side, we need to find the theta. So theta is equal to W0. W0 is given to be 3. We are t is equal to be 3 plus half into alpha. Alpha is given to be 4. The time is given to be 3 seconds. Okay, at the time of 3 seconds. So this is 3 square. So 2. So 9 plus 2 into 3 square is 18, right? This is equal to 27 radians. Okay, so answer is 27 radians. This is the answer. Okay, let's go to the next question now. What is the linear velocity if the angular velocity is given to be this, right? So we, in the concepts, if you remember, there is a formula which we had written. We had written formula V equal to omega into R. Okay, we written this formula in the concept. If you go and look at the concept, the formula, you should be able to find this formula. So we need to find the linear velocity here, which is V. We need to find this here, and what is given to us is that omega and position vector R is given to here, right? So with a cross multiplication, so I j k. So I omega, we need to find it. So omega is 4i minus 5j plus 3k. 4i minus 5j plus 3k. So, and what is R? R is 3i plus 4j plus 5k. Okay, so we need to find this. So this is equal to, if we take I now, so minus 5 into 5 is minus 25, minus 3 into minus 12. So minus 25 minus 12 is minus 37, right? Okay, now let's take a j. So minus j, right? Minus of j. So 4 into 5 is 20. 20 minus 9 is 11. 20 minus 3 into 9, 11. Okay, minus 11 j. Okay, now let's go k. So k is plus of k. 4 into 4 is 16. 16 and minus of minus 3 into 5 is minus 15. Minus 15 is plus 15. So this becomes 31 k. Okay, so the answer should be the second one, right? Right, so friends, so these are all the answers we had to the questions. Okay, so we'll have more questions in the future videos. So friends, we hope you like this solution to the problems. If you don't like them, please feel free to add your review comments, and so we can go ahead and try to improve upon them. If you are liking them and it is helping you, then we request you to like the video and subscribe to the channel. Okay, so we hope to see you back in this channel soon. Okay, thank you.